Hi, my name is Sebastian and welcome to this video about VPN vulnerabilities. So, why are we doing this video now? Well, maybe you've seen the news. So a few weeks ago there was a vulnerability that was released called TunnelVision, and in last August there was other vulnerabilities called TunnelCrack that were released, and you've maybe seen all these news articles. They say things like these are massive security holes and virtually all VPNs are unusable. They have, of course, logos and they have CVE numbers and everything that's accompanied with massive vulnerabilities. Okay, so what are these? Well, they are attacks on VPN devices. That's why they are called tunnel, because a VPN creates a tunnel. You can think of a VPN app as doing two things. Doing file encryption. So say you have a file that you want to encrypt. You send it through something that encrypts it. And then the VPN app also uses routing to send the packet to where it should go. And since this is two different steps, there's a fundamental flaw here, because the VPN app can really only control the encryption part, but it can't control the routing. So for the routing, if you have an app on an operating system, you have to rely on the operating system. And the operating system itself also relies on unprotected internet services, which of course sounds bad, and it's quite bad. So the reason why these are unprotected comes from the internet history. When internet was invented in the 80s and so on, all the protocols were unsecured because there were no attackers on the internet. So protocols such as DNS, for example. DNS is a protocol, you can think of it as an address book. So in the DNS records, it can say that Sebastian, for example, lives at 222 in Malmö. That's my address. So if somebody wants to send me a mail, they will look up Sebastian and then they will see that they should send it to 222 Malmö. And DNS is one of those protocols that we are going to discuss here. Another protocol is DHCP, which assigns dynamic addresses to web servers and hosts. You can think of this as moving around. So if I move from one apartment to another, from, for example, 222 Malmö to 333 Malmö, then I get a new address. So my new address would be 333 Malmö. And that's that's the DHCP that gives me the address. There are also in the internet many other insecure services. I won't mention all of them today, but there's quite a lot. So, for example, routing generally, there can be issues with security, and time, for example, can also be one thing where you can get, and lots of other protocols. So there are ways to secure these. DNSSEC is one option, for example, but this is usually not used, so it's not very widely adopted. The thing to consider here is, why do you use a VPN? So who is the attacker and what are you trying to protect against? One use case or one risk here is that you connect to a Wi-Fi hotspot and that the hotspot is actually evil. For example, you sit in a cafe or you sit somewhere where somebody spoofs a hotspot. They just need to use the same SSID and you might automatically connect to it. In that case, you want to use a VPN to protect yourself. The problem here is that if you do this, then you might be vulnerable to these attacks. So I would say that the attack is actually quite relevant for most VPN applications. I will start with the TunnelCrack. One of the TunnelCrack, there's actually two parts of the TunnelCrack. So the first part of the TunnelCrack is, well, actually two different CVEs, two different vulnerabilities. So one of the, but both of them are called TunnelCrack. So the first one, which has been dubbed the TunnelCrack LocalNet, I will start with that one. It actually has several CVE numbers, but you can think of it as one attack. So the trick here is that the VPN device usually does not encrypt traffic that it wants to send directly on the local net that are locally reachable. So you might have a file server locally, or you have some other thing that you want to access that is directly connected to your client. So you don't want to use the VPN tunnel for this. And this is the standard way to configure it. Is in this case, this is fine. You don't want to encrypt this information. However, if you connect to a rogue hotspot, then it has a DHCP server that gives you an IP address, and it might trick you into actually using a public address for your local network. So it gives you this address and says this is your local address. Now the problem is, if you want to send traffic to this IP, the VPN app will think of this as unencrypted, or that it should be unencrypted. However, the communication, you might want to contact your bank, for example, and if your bank has the same IP as the that the Wi-Fi router gives you for your local network, then you will send unencrypted to the Wi-Fi router, and the router will actually do a man-in-the-middle attack. So it will take the information and send it to your bank, and the bank will reply to the router, and you will get this information back, but everything will be passing the Wi-Fi router and unencrypted. So the encryption part will only be from the router, which, and then the attacker has the key towards the bank. So you are susceptible to this attack if you don't check that what you have gotten in your private network is a public address. So this can be checked against, and this was patched by, I would say, all VPN, serious VPN systems, that you don't route public addresses locally. So that's one part of the tunnel crack. The second part is the remote IP attack, and this uses a feature of an implementation issue with how the VPN apps work. So they use routing internally on the operating system to send packets, and they route all the packets to the encryption interface, and when they get back the packets, they see, okay, this one is encrypted, and then they send it out towards the destination using the public interface. That's the Wi-Fi, for example. And the issue, this might sound reasonable. The issue here is that if an attacker can spoof the DNS record, so let's say you want to contact bank.com, but instead the DNS server says to you that, okay, use the IP that's the IP of your VPN interface, your VPN IP. So in that case, you would actually send the packet directly to the router without, or you could potentially send the packet directly to your router and then unencrypted. The reason is that you want to avoid this loop, which can happen if you send it again and again and again to the encryption interface. There are, of course, many ways to prevent this to happen. You could filter out packets on a much better than just using the destination IP. So you could verify that the packet is indeed encrypted. This is usually not, well, this was a possible attack vector on many implementations before. You could also have firewall rules to prevent this. But according to the paper that was released, quite a few were vulnerable to this type of attack. Of course, you need a rogue DNS server, but it's not impossible to achieve this as an attacker. The one from this year, from 2024, has been dubbed TunnelVision, and it uses also DHCP, however in a different way. So in this case, the DHCP protocol allows an option called 121 to give the client, or victim in this case, a special routing rule that can then bypass the VPN. So if the client accepts this route, then it might send traffic directly to the public interface without actually using the VPN. This can be solved, of course. I think the main way that it has been solved is to actually disable the DHCP option 121, because it's very rarely used for any purpose. And now the possibility is, of course, to actually use firewall rules internally, so on the laptop, so that these packets won't be routed to the internet. Those are our possibilities. There's actually one more possibility for the TunnelVision. So I think we can call it the TunnelVision remote attack, and this consists of the use case where you have a travel router that also is a VPN. So you run a VPN software on the travel router, and the attack would be against this travel router. So the travel router accepts DHCP because it has to get internet somewhere. And if it connects, for example, to a hotspot in some way, then you would it would get a route. So, and in this case, if it accepts this route 121 DHCP option, it could potentially route packets incorrectly in the same way as your client would, so like the laptop would. So this could potentially be an attack. I'm not sure if any of these if there's any travel routers like this that are vulnerable or not, because the attack is quite new, and also this was not really the point of the paper. The paper was attacking the client that was running the VPN app. But that's also a potential risk. So I hope these 4 use cases, maybe they are a bit clearer now of what the point is of the attack and how it's performed. So Advenica has 2 products that are related to this. We have one VPN system, which consists of hardware devices, and our VPN system is not vulnerable to these issues. If you've listened to my previous webinar about top secret products, there I mentioned high assurance, and to achieve high assurance we use red-black separation, and this consists of separating red unencrypted data and black encrypted data, and the only way to pass this barrier is to go through the encryption process. In this case there is no routing going on, just encryption. So this design is secure against these type of flaws. This might not be the best option because having a separate box can be expensive and clumsy, but it does add security, which has been illustrated here, and it also can protect against some other use cases, some type of viruses, for example. So this is something to consider. Our other type of product that is related to this is security gateway. So we have a product called ZoneGuard, which performs domain separations. So it separates one domain from another, and we do not route packets through these domains. What we do is we disassemble the protocol on one side, we take the information and we rebuild another protocol or the same protocol on the other side. And in this case there is no routing going on, so this type of attacks, they do not affect the security of these products. Okay, thank you for listening, and hopefully you can listen to another webinar in the future. Bye.